In this lab, I will challenge the common misconception that the mass of an object has an effect on the rate at which an object falls, and thus the time in which it takes to reach terminal velocity. The purpose of this lab is to analyze the effects of mass on a falling object's velocity. In order to do this, we will compare the velocities and acceleration of the two objects and create a model showing the forces at hand. Here are the videos we will use to analyze. The first one shows a normal coffee mug, which weighs about a half a kilogram, and the second one shows a coffee mug filled with coins, which weighs about 1.3 kilograms. Both were analyzed in Tracker, as seen here, with the origin about the center of the mug and the length of the latter used as the calibration stick. Here we can see the velocity data of the two videos. As you can see, the velocity for both seem to be around the same, right about 6.5 meters per second. While it appears that the velocities are still changing slightly, it also looks as though both have come very close to reaching their terminal velocity. We can tell this by the flattening of the slope of the line as the graphs reach 0.6 seconds. Let's discuss some of the physics happening here. While common reasoning leads one to rationalize that an object with greater mass also has greater gravitational force and will therefore reach terminal velocity faster. This is not so, however. As we learned earlier this semester, inertia is measured as the amount of energy necessary to move an object. The coffee mug with the higher mass will also have a higher inertia. The differences between the inertia values and gravitational force values between the two objects will cancel out, producing two free-falling objects at the same speed and acceleration. It is important to remember, however, that if the shape of the second object was different than the shape of the first object, our results would be drastically different. This is due to the effect of surface area on air resistance. Due to the shapes of the two objects being the same, we can exclude any difference in air resistance between the two. Referencing a similar code as the one used in Lab 2, we can see the models produced by Python showing both the effects of drag force and gravitational force of an object. As we can see, the drag force of the object does not change as a result in change of mass, and as mentioned earlier, inertia will play a role in canceling out the differences in gravitational energy. In conclusion, we were able to determine that an object's mass does not influence its velocity or the time it takes to reach its terminal velocity when falling, as long as the shapes of the objects are the same. There were a few sources of error in this lab. The main error was lack of video quality. Because of this lack of quality, it was extremely difficult to obtain the correct point masses as the object fell, thus skewing some of our velocity data. We also have to take into account that there may have been some force on the mug from the hand when the object was dropped.